This instructional video is designed to show how we would use information gained from the method of initial rates to look at a reaction data and determine what is its rate law, what is its rate constant, and what is the half-life given these initial quantities. So the first thing we want to do is determine a rate law, and for that we have to do comparisons. So I'll compare number 1 versus number 2, and then trial number 1 versus trial number 3. And what we find in going from 1 to 2 is that we have twice the concentration, and that results in going from a rate of 3 moles per minute to 12 moles per minute. So that's 4 times the rate. When we compare 1 and 3, we find that if we do 3 times the concentration, this results in 9 times the rate. And so this conclusion tells us that we have a second order reaction in terms of our oxygen concentration. So the rate law then is the rate constant times the square of our oxygen concentration. And so this answers our first question: what is the rate law? For the next one, we simply have to solve this expression for the value K. So we're going to take that K equals the rate divided by the square of our oxygen concentration. So this means that we have 3 moles molarity per minute divided by, for trial number 1, that's 5.0 molar squared. And so 5 squared is 25. 3 divided by 25 gives us 0.12. And for our units, we find that one of these molarities will cancel. So our units are 1 over minutes times molarity. So this answers the question of what is the rate constant. The final thing we have to do is determine the half-life of the reaction. And in this case, because we have a second order reaction, we have that 1 over the concentration at time t will be equal to the rate constant times temperature, times time, sorry, so that's 0.12 times t, and we're going to add to that 1 over the initial concentration. And now, because this is a second order reaction, we know the form of T1/2, and that's going to be 1 over the rate constant times the initial concentration. So this is 1 over 0.12 minute times moles times that initial concentration. And so for each one of these, we'll have a specific value. So for run number 1, what do we find? 1 divided by 0.12, and I'll be suppressing the units for ease of writing. The initial concentration here was 5 molar. And so if we multiply through properly, we get 1.67 minutes. For run number 2, that half-life is, again, the rate constant, 0.12 times 10, and all of that is in the denominator. So this gives us a value of 0.833 minutes. And finally, for run number 3, 1 over 0.12 is 15, and that gives us a value of 0.556 minutes. And so this gives us then a half-life for everything. And what we find is that we have the form of the rate law, where it's second order. We have a value for the rate constant. And because it's second order and we know the formula for our half-life, we can then find for each one of the trials from our initial data set what the half-life of the reaction will be.